dot product and cross product. The dot product of two vectors is written as this: A dot B. Dot product of vectors is equal to the summation of product of similar components. To get the angle between vectors, obtain first their magnitude. Recall that the formula of magnitude is square root of summation of square components. Then, we can now find the angle between vectors by this formula. Theta is equal to arc cosine of dot product all over magnitude A times magnitude B. Orthogonal components are simply dot product over magnitude A, dot product over magnitude B, or magnitude A cosine theta, magnitude B cosine theta. The cross product of two vectors is written as this: A cross B. To find the I direction, simply cross multiply J and K components, same as the J direction and K direction. J is equal to cross multiply I and K. K is equal to cross multiply I and J. Now, example. Let us use the matrix printed in the screen. Vector A is equal to negative I plus 3J plus 5K. Vector B is equal to 2I minus 4J plus 6K. A cross B is equal to 3 times 6 minus 5 times negative 4 minus negative 1 times 6 minus 5 times 2 plus negative 1 times negative 4 minus 3 times 2. The final answer is 38I plus 16J minus 2K.
Good day everyone, I am here to explain how we made a program for calculating the dot product and cross product of vector quantities. So the vectors that we will use today is this. From these vectors, we are going to find the angle between vectors, orthogonal components, and the cross products. First, we are going to make the program for solving the angle between vectors. In order to do that, make a table for our vectors. The vectors that I will use for now is vector A and B, but later, after the program is finished, we will try the vector B and C and vector A and C. After that, we can compute the dot product by multiplying the I components of A and B, and the same with J and K components and adding their products. So in Excel, we can just type open parenthesis and click for the I component times the I component of vector B plus open parenthesis the J component of vector A times the J component of vector B plus the K component of vector A times K component of vector B. So that's the answer for our dot product. After that, we should get the magnitude of vector A and the magnitude of vector B. And to do that, get the sum of the squared component and square root the answer. In Excel, we can just type As you can see, the magnitude of vector A is 9.69. So for magnitude of vector B, we can just copy paste this with this. The next one is the angle between vector A and B. To get the angle between vector A and B, divide the dot product of vector A and B to the magnitude of vector A divided by the magnitude of vector b, then get the arc cosine of the answer. In Excel, we can just type so the angle between vectors a and b is 94.18. And that's done. We got the angle between vector of b with the use of dot product, magnitude of a, and the magnitude of vector b. The next one is getting the orthogonal component of vector a and b. To do that, again get the dot product, the magnitude of a, and the magnitude of b. But for it to be easy, we can just copy and paste again. As you can see, it is the same process as the previous one. The same for the magnitude of A and the magnitude of B. The next one is getting the orthogonal component of vector A and B. And to do that, in Excel, we can just divide the dot product with the magnitude of B. So in Excel, you can just type and we are done. The orthogonal component of vector A to B is negative 0.71. The next one is creating a program for the cross product of two vectors. We are going to use here again the vectors A and B. To get the cross product of I, multiply AYJ to BZK, then minus to the product of AZK and BYJ. In Excel, you can just equals multiply this to this minus this. So in here, for J, we can just type negative multiply AXI to BZK, then minus to the product of AZK and BXI. And for K, multiply the AXI to BYJ, then minus to the product of AYJ and BXI. So in Excel, you can just enter. And we're done creating a program for calculating the cross product of two vectors. So the answers are 45i, 21j, and 47k. So this is the answer for the angle vectors of A and B, 94.18, and its orthogonal component, negative 0.71, and its cross product. Now, I will try to solve the other problems using the program that we made. For the orthogonal component of vector B to A, we can just swap this. So for the orthogonal component of vector B to A, the answer is negative 0.52. So for vector B to C, now for vector A to C, and C to A. That's all, and thank you for watching.
In this part, we are going to explain how to solve the given problems manually. So, these are the given problems. First is the dot product application part A, where we have to find the angle between two vectors. And the next problem is dot product application part B, which we are going to find orthogonal component of the two vectors. And the third problem is getting the cross products of the two vectors. So these are the given vectors. So in the first problem, which is getting the angle between the two vectors, first let's try vector A and vector V. So in getting the angle between two vectors, let's first get the magnitude of the vectors. So in getting the magnitude of the vector A, we will be using Pythagorean theorem where we square the given and square root it. So these are the formula, and then just substitute those given numbers, and then you'll solve it and you'll get 9.695. Same as the vector A. In getting the magnitude of vector V, we are also going to square it and square root. Then you are going to substitute those givens in the formula, and then you'll solve it. You'll get 7.071. After getting the magnitude of two vectors, we are now going to multiply the two said vectors. In multiplying the two vectors, the formula that we are going to use is the vector A multiplied by vector B is equals to AX times BXI plus AY BYJ plus AZ BJK. Then substitute the given to the formula, and then you solve it, then you get -5. After multiplying the two vectors, you can now get the angle between the two vectors. So, in getting the angle between vectors, the formula is theta is equals to inverse cosine multiplied by vector A multiplied by vector B over the magnitude of vector A times the magnitude of vector B. So in substituting the given, solve, and then you get 94.183 degrees. So that is the angle between two vectors. So in getting the angle between the vector B and C, you just have to do the same process in what we do in getting the angle between vector A and vector B. Since we already solved for the magnitude of vector B, we are now only getting the magnitude of vector C. So this same process, and then you get 12.884. After getting the magnitude of vector C, we are now getting or multiplying the two vectors as what we did before. Like that, substitute the formula, and then you'll get 73. And then after that, since you already multiplied the two vectors, we can now get the angle. So the same process, substitute to the formula, and then you get 36.746 degrees. So you can just do the same process in angle C and in getting the angle between vectors A and vector C. After solving all of that, we now have the angle between the two vectors. The angle between vector A and vector B is 94.183 degree, and the angle between
vector B and vector C is equals to 36.746 degrees, and the angle between vector A and C is equals to 88.624 degrees. So now that we are already done in solving the dot product application part A, we are now going to proceed to dot product application part B, where we are going to find the orthogonal component of the vectors using dot product. So in solving that, we are going to use the magnitude that we solved before and the multiplication of the two vectors that we also solved before. So the formula in getting the orthogonal component of the two vector and vice versa is vector A multiplied by vector B divided by the magnitude of the vector A. And then if we're going to substitute that in the given, and then we'll solve it, and it will be equals to negative 0.516. Since we are going to get the vice versa of what we solve, we are just going to replace the dividend, which is from magnitude vector A to magnitude vector B. So in that way, we can now get the vice versa of the orthogonal component of the vector A. Then same process, substitute the given in the formula and then solve, then you'll get negative 0.707. And then you just have to repeat the same process for the remaining vectors. And now that we already solved the dot product application part B, we are going to proceed in getting the cross product of the vectors. So in doing so, the first we need to do in getting the cross product of the two vectors, you're going to lay their given, so it will be easier for us to tell which are the I, J, and the K. And after that, in getting the cross product, we will proceed to the formula, which is A y times bj minus aj times byi minus ax times bj minus aj times bxj plus ax times by minus ay times bxk. Then substitute the given in the formula and then solve, and then you get the answer, which is 7 times 3 minus negative 6 times 4 is equals to 45i, and then minus 3 times 3 minus negative 5 times negative 5 is equals to 21j, and then 3 times 4 minus 7 times negative 5 is equals to 47k. In getting the cross product of other vectors, you just have to repeat the same process on what we did in the vector A and the vector B. So this is the table for summarization of the answers, and that's all. Thank you.